Okay, good day class. So for our chapter 2 sa aton nga quantic chemistry. Okay, so we will be discussing about the measurement of your analytical chemistry. You will be focusing on the measurements na. Also, don't worry because since this is quantitative chemistry, we will be uh, counting or measuring small particles or mga muna with the help of a machine. Pero the theory behind the using of machine or ang iyang pag-calculate is what we will be studying. So, why gid man sa gawa calculation? Because calculation here is quite complicated that also needs a help of your scientific calculator. Kag hindi sa and hindi mo gid naman sa manually count because you'll be needing the help of your spectrophotometer to count all the particles inside your given nga sample. So without further ado, let us now start our discussion. So measurement in your analytical chemistry. Analytical chemistry is in a quantitative science, whether determining the concentration of a species or evaluating an equilibrium constant, measuring mga reaction rate, also drawing your correlation between your compound structure kag also ang iyang nga reactivity. Okay, ang imong analytical chemistry engage in the measuring important chemical things. Okay, in this section, we'll be review briefly the basic units of your measurement and also the proper use of your significant figures. Now, let us focus on units of our measurement. Okay, a measurement usually consists of a unit and a number that expresses the quantity of that unit. We can express the same basic measurement with different mga man nga unit if you know how to convert or may mga conversion factor ka mo to change that given nga value, which creates the confusion we are not careful to specify the unit. For example, the mass of a sample weigh around 1.5 grams. Okay, it is equivalent to 0.0033. Anong LB? It is in pounds or 0.053 ounce. To ensure your consistency and to avoid your mga problems, scientists use the common set of fundamental base units listed in table 2.2 na 2.1.1. This unit is what you call your mga SI units after your System Internationale. Okay, the next. This is important. It is very important for mga scientists to agree upon your set or common set sa conversion factor. In 1999, for example, ang NASA lost sa Mars orbiter spacecraft because one engineer team used English unit sa ilang calculation. Ang English unit is under the mga meter, mga muna. And also, another team used metric units. As a result, the spacecraft came too close to the planet's surface, causing its propulsion system to overheat and also fail. Some measurements, such as your absorbance, do not have unit because the meaning of your mga ibang nga mga calculation is unitless. Ibig sabihin ng mga number lang sila often is unclear. Some author include artificial unit. It is not usually to be seen in your abbreviation or mga AU. For short, your absorbance unit. Okay, amo nang iya nga AU. It is just only a representation but it is not a unit. Okay, following the absorbance value which helps clarify that the measurement is absorbance value. Next, you have here measurement unit, also ang iyang symbol kag mga definition niya. If you have here a mass, okay, for example, your mass ang iyang unit is in kilograms, then also iyang symbol nga kg. Okay, you also have the definition here. For the mass is international prototype, okay, object house of international diploids and measures the seviers in France. Usually, kung sa diin sila nga country ginagamit, you have here sa France. Then you have international prototype changes the ratio approximately 1 microgram per year due to reversible surface contamination. The reference mass, therefore, is determined immediately after cleaning using specified procedure. Current plan calls to retiring the original prototype of defining kilogram in terms of Planck constant. You have here distance. So, hindi nagamay ang siya ko na utog. Kaya you have here sa aton nga distance, ang importante na lang you have distance, your meter, and also yung symbol. Then you have here for your temperature. Temperature is in Kelvin, and yung symbol is into K. Nadula ko. Hindi na sa math. Then you have your time. Time is in seconds, and small letter S. You have here, ano man lang sila, example of its usage. Then you have here measurement, asing yapon, pero dire, it is for your electricity. You have your current, measurement for your current, it is in ampere, symbol is letter A. Then you have your amount of substance, mole, and also mole. Feel ko na-discuss nyo naman sa aton nga mga general chemistry. Okay, you have here, for the light, you have your candela and CD. There is some disagreement the use of amount of substance to describe the measurement of which a mole is based in your SI. Okay? Kung ano yung mga SI, what is the name of the substance, amount of your substance, it is called for a chemical amount and also stoichiometry amount. The reference value sa book ni Guanta. Wait, let me pause on it. Okay, now so let us continue sa length. Okay, for your length, you also have the unit angstrom. Angstrom is a non-SI or non-standard international nga unit. We have here yung symbol, it's capital A with nga may bilog sa babaw. Compared mo sa imong nga ampere which is only letter A. Then you have here yung equivalent SI unit. If you have a 1 angstrom, it is equal to 1 times 10 raised to negative 10 meters. Then you also have here sa atong volume, we have here liter, then symbolize letter L. Okay, you have here in every 1 liter is equals to 10 raised to negative 3 meter cube. Okay, it's M3. Then you have for your force, your Newton is SI nga unit. Your symbol is capital N. In every 1 Newton, you have 1. Okay, you have 1 M kilograms per second square. It is ang mga meter times mo sa kilogram divided by meter divided by second square. Then for your pressure, your common measurement for your pressure is your Pascal, that is your SI. And for your non-SI unit, you have your atmosphere. Okay, for your Pascal, the unit for your Pascal is P and small letter A. It's capital P and small letter A. And for your atmosphere, it is ATM. In every 1 Pascal, you have a 1 Newton per meter cube. And it is also equal to 1 kilogram, okay, per meter second square. Okay, and also if you have a 1 atmospheric pressure, it is equal to how many Pascal? It is equal to 101,325 pascals. It's like this is for your conversion of your 1 ATM into Pascal. Then also pwede kita kakuha sa mga Newton if you want to solve kung pila gid yung mga force sa mo na nga equation or mo na nga problem. Next, you have here your energy and also work kag heat. Okay, for your energy, you have here your joules. Your energy is in calorie. Then for your volts, then for your joules, it is your SI unit. It's capital letter J per calorie. It is CAL, and you have your electron volts. It is a non-SI, which is small letter E for your electron, and capital V for your volts. Yung ilang equivalent value, you have in every 1 joules, okay, it is equals to 1 N or Newton meter. Then, it is equals to 1 meter squared times kilogram per second squared. Then, for your calorie naman yung glass, in every 1 calorie, you have 4.184 joule. And in every 1 electron volt, okay, you have 1.602 177.33 times 10 raised to negative 19 joules. It is only your conversion factor yung equivalent units. Okay, para pwede ka silo-silos ang units mo. Then for your power, you have watts. Capital W na yung mga watts. In every 1 watts, you have 1 joules per second. Or it is also equal to 1 meter squared. Okay? Kilogram second cube. Then for your charges naman yung class, for your charge, you have your column. Okay, it is a capital C. In every 1 column, you have a 1 ampere per second. It is capital A. Ang capital A mo ganun divide is ampere. Okay, then for your S, it is seconds. Then for your potential, you have your volts. In every same mga volt is capital V. In every 1 volt, you have 1 watts per ampere or also equal to 1 meter squared times kilogram per seconds cube multiplied with your ampere. Then for your frequency, okay, frequency is in hertz. It is capital H, small letter Z. In every 1 frequency, you have in every second raised to negative 1. Then for your temperature naman yung class, okay, it is Celsius. Okay? But it is a non-SI. Kaya ano ganyan ito nga standard internationally for our standard unit for your temperature, it is in Kelvin. Okay, so it is in Celsius ay mo non-SI. It is degree Celsius. Okay, mga conversion factor is if you are given with a Kelvin, okay, para mag-solve ko sa imong Celsius, simply subtract 273.15 from your Kelvin nga unit and you will have your Celsius nga value. Now, okay, chemists frequently work with measurements as they are very large or very small. A mole contains 600 to pila ni? Tas niya. More than 1,000 billion, billion, trillion, 213, 670, zeros, wala ka zero ni. 1, 2, 3, 4, 5, 6, 7, 7, so 21. So do around 21 nga exponent kung scientific notation. Particles and some analytical technique that can detect as a little of 0.000, pila ka 0, 3, 6, 9, 12, okay, and 14 ka 0 grams of a compound. For simplicity, we can express this measurement into your scientific notation. Okay, aton nga scientific notation here, you have your 6.022. Okay, it is the same value here sa babaw. Express into scientific notation. Times 10 raised to 23. And ang ari sa aton nga it is 1 times 10 raised to negative 15. Okay nga, nag-negative 15 siya class. Because if, again, move mo yung decimal point from this point hasta sa pinapunta sa 1, giving you a value of 1. Kaya di ba pala? 14 lang ni ka 0. 1, 3, 6, 9, 12, 13, 14. So it is negative 14 pa lang. Kung ma-move ka pagid 1 pa from left to right, it will gain negative pang exponent. Therefore, it is negative 15. Okay, sometimes you wish to express measurement without the exponential term, replacing your prefixes. Okay, kaysa nga mag-ano ka sa imo nga scientific notation, we will be using your prefixes. For example, you have a 1FG. FG or your F, okay? The prefix F stands for femto. And for the grams, okay, it is the unit of your measurement. It's a 1 femtogram. Writing lengthy numbers with the spaces instead of commas may strike you unusual. For example, for a number more than 4 units. Okay, on either side of your decimal point, however, the recommendation from the International Union of Pure and Applied Chemistry, okay, is to use the space instead of a comma. We have here mga prefixes. Your iota, okay, your iota is capital Y. Kaya ang iyang conversion factor or ang iyang value mismo is or yung factor is 10 raised to 24. And for your zeta, zeta is capital Z. It is 10 raised to 21. For your eta, it is 10 raised to 18. Capital E ang symbol. For your peta, it is capital P, is 10 raised to 15. Your tera, okay, it is capital T, it is 10 raised to 12. For your giga, it is 10 raised to 9. For your mega naman, it is capital M and 10 raised to 6. Okay, sa imong mga small letter, although ang ilang value is taas pagyapon, okay, you have your kilo. It is now lowercase letter k. Factor is 10 raised to 3. For hecto, small letter h. Okay, then 10 raised to 2. And for deca, it is 10 raised to 1. Then you have here this equal value or wala sang change o sa prefixes. Okay? For example, may unit ka di nga grams. Okay, if your grams or the value exceeds or nga exponent around 24 nga exponent, therefore it is iota grams. Okay, it is capital Y, small letter J. Muna siya. And when you look at here class, ang makita nyo, it is going down by 3. Okay, except na didiri sa kilo. Okay, after sang imo kilo, you have your hecto which is 10 raised to 2 and for your deca, 10 raised to 1. For your deca, tandaan nyo lang, deca, it is a small letter D with an A for your deca. So, yung muna natin talandaan kung i-familiarize. Then, we go with the lower values. You have your deci. Deci is a lowercase na D for your symbol and the value is 10 raised to negative 1. For your centi, it is small letter C or lowercase letter C, it is 10 raised to negative 2. For your milli, it is small letter M, 10 raised to negative 3. Your micro class is a kind of a symbol or a unique symbol. Kumbaga pa, if you look at it, it is like the icon for your uTorrent. Okay, you write it like do H nga baliskad. Okay, do reversible yung H. You have here may tingkoy siya sa unahan, then a small tail sa punta. Okay, the factor, yeah, is 10 raised to negative 6. For your nano, it is small letter N with 10 raised to negative 9. For your peco, it is small letter P, it is 10 raised to negative 12. Your femto, letter F, and it is 10 raised to 15. Your ato, okay, it is letter small a. For your zepto, and for your yocto, which has the factor of 10 raised to negative 21 and 10 raised to negative 24. Okay. What do you, ano po yung mga observe in the class? Okay, ang yung mga symbol, okay, usually came with a first letter sang imo nga prefix. Okay, for your yokto, it is small letter Y. Kaya tandaan nyo, around sa maglabot, naka sa imo nga milli, okay, milli to micro, it is already by 3 na ang increase. You have your milli, micro, nano, pico, femto, ato, zepto, and yokto. Kaya ang imong pa-erase ang imong or pagnubo sa imong mga exponent is by 3 na. Now, uncertainty in measurement. Okay, measurement provides information about both its magnitude and its uncertainty. Consider, for example, 3 photos of your diri sa dalom. Okay, taken with an interval of approximately 1 second after placing a sample on the balance. Assuming the balance is properly calibrated, we are certain that the sample mass is more than 0.5729 and less than 0.5731. We are uncertain, however, about the sample mass is the last decimal place since the final two decimal places fluctuates between 29, 30, and 31. Okay, the best we can do in this is to report that the sample mass, okay, is either around sa pag mga middle, which is 0.5730, positive or negative 0.001 grams, indicating both its magnitude and its absolute uncertainty. Yung niya na is you have the same sample but they are weighted in different time interval. Okay? Katatlo mo siya gin-weigh. Okay? Giving you the difference or different na mga weigh. You have 0. Dire. You have your 30, your 31, and 29. Okay? Kinpili ya ang sa tunga which is your 0.5730. Okay? Then nagbutang siya sang another nga equation sa tupad sang imo nga calculated nga mass which is your 0.001. Okay? Ibig sabihin na it's either ang mass sang imo nga sample will increase by 0.0001 or decrease by 0.0001. It's either makakuha ka sang 31 kag 29 kag 30. Niya nga indication. Now, let us proceed sa aton nga significant figures. Galag. Okay. Your significant figures, okay, convey the information about the measurement, magnitude, and uncertainty of the number of your significant figures in a measurement. Is the number digitally known exactly plus one digit and whose value is uncertain? The mass shown in your figure sa atong sa babaw, for example, has four significant figure, three of which we know exact and one, the last, which is uncertain. Okay? Suppose we weigh a second sample using the same balance and obtain the mass of 0.0990 grams. Does this measurement have 3, 4, or 5 significant figures? The zeros on the last decimal place is the one are your uncertain nga digit. Okay, and it is significant. The other two zeros, however, simply indicates the decimal points location, writing the measurement as your 6.0 as 6 man, it is 9.90 times 10 raised to negative 2. Clarifies that there are three significant figures in your given nga sample. Eh, how do you know sa atong significant figures? Sa general chemistry, we'll be discussing na sa significant figures nga paano mag-identify sa mga units nga hindi na required. We have here, if it is written in a scientific notation, ano, di ba class, ang tanan nga multiplying factor is significant. Therefore, you have three nga significant figures. Okay, this clarifies that there are three significant figures in your nga value. We have here solutions ang ano, if you have three sa imo nga nakat isa, inabili na lang isang NaOH. Okay. Sorry, na utod gini. Okay, for your you have here significant figures for HCl, four significant figures for your CCO3, and four significant figures for your buday discuss kung kulang aton nga no inagkatid sa yung dula. Okay, sa dili na lang ko sa kay nga nag four significant figures isa. Okay, if you're talking about significant figures, all your non-zeros is from 1 to 9 is considered significant. Then ang mga zero, okay, that are being irrelevant here, which is the 1 at sa 4 nga zero sa unahan. Okay, ang zero nga nagpatung-an sa imo 1 kag 4 is considered significant. Then you have here two significant figures lang sa imo nga 93,000 milligrams of your NaOH nga tatlo nga duwa lang because all zeros pwede galing na bilis ka lang okay kabubagid sa that's why mawala na mag-download kaya nagbalis ka lang isa okay you have here okay, ang zero nga green is considered significant and the zeros red are not significant sa diri. Then, you have here sa atong nga sample nga three significant figures lang because you have the zero nga ara sa punta sang imo nga and sa imo nga 120. Okay? Then, ang imo nga 4 significant figures here, because you have 605.3. Okay, tanan nga non-zero units, which is from 1 to 9, is considered significant. And ang zero nga napatungan mo sa imo nga mga non-zero, which is 6 kag 5 day, is considered significant. Therefore, you have 4 significant figures. Then, for your dili nga value, okay, 4 significant figures siya because ang zero nga isa ni napatungan, then ang zero nga ari sa unahan sa imong value is not considered significant. Then diri ha, you only have two significant figures because non-zeros lang ang ginaisip di. Kag ang zeros nga sa punta are not considered significant. Nung pagkalain niya ka sa diri, okay nga ang zero sa punta ginisip niya as significant, naging 3 significant figure siya compared mo dire because this is a decimal value. Ang ginambal di, all zeros that are found, okay, sa right side sang imo nga zero, sa imo decimal point, and sa left side sang imo nga non-zero, which is your y, okay, will be not considered significant. Diri man, if you're given with a whole number, kaya ang imo decimal point, ara ginay dapat sa punta. Okay, it is given. Kaya may decimal point ka di. All zeros that are found at the left side sang imo nga non-decimal point kag sa asa imo right side sang imo nga non-zero, which is your 3, are not considered significant. Therefore, these are red. Okay, that therefore duwa lang imo significant figures. Okay? There are two special cases when determining the number of significant figures in a measurement. For a measurement given in a logarithm, such as your pH, the number of significant figures is equal to the number of digits to the right of your decimal point. Digits to the left of your decimal point are not significant since they indicate 10. Okay, a pH of 2.45 therefore contains two significant figures na. Okay, you have here the log of your 2.8 times 10 raised to 2 is 2.45. The log of 2.8 times is also 4.5 lang. Muna ni ang ginafokusan mo. Okay, the log of 10 is 2. Then 2 is the 2 in 2.45 therefore only indicates the power of 10. Therefore, it is not significant. Okay, the exact number such as your stoichiometry coefficient has the infinite number of significant figures. A mole of your calcium chloride, for example, contains 2 moles of your chloride ions and 1 mole of your calcium ions. Another example of the exact number is the relationship between some units. There are, for example, exactly 1,000 milliliter in 1 liter, and both 1 and 1,000 have infinite number of your significant figures. Using the correct number of your significant figures, it is important because it tells us other scientists about the uncertainty and also sa nga measurement. Suppose you weigh a sample on a balance and measures the mass to the nearest of 0.1, positive or negative 0.1 milligrams. Reporting the sample's mass is around 1.782 instead of 1.723. Okay, it is incorrect because it does not convey the proper measurement or uncertainty. Nga man, dapat dili ka nagdugang sa first mga value which is your 7. It's either magiging 1.862 siya or maging 1.762 or maging 1.662. Okay? Reports the measurement is incorrect because you are falsely suggesting sa dilim ka nag-change sa nagdugang ka. Okay? It also is also incorrect because it fully suggests the uncertainty of your 0.01 milligrams. Okay, concentration. Okay, concentration is the general measurement unit to report the amount of solute present in a known amount of your solution. Your amount of solute is equal to, or amount of solute concentration is equal to the amount of solute divided by amount of your solution. Although we associate the term solute and solution with liquid samples, we can extend the use of your gas phase and also solid phase sample as well. Table 2.2.1 listed is the most common units of your concentration. Common units for reporting your concentration. Okay, you have here your molarity. Okay, your molarity is equals to moles of your solute over liters of your solution. Okay, the symbol for your molarity is capital M. Then your lapit lang ako, formality. Okay, it is the moles of solute over liters of your solution. Okay, for your formality, it is capital F. For your normality, it is the equivalent of solute over the liters of your solution. Okay, it is the symbol of capital N. And in your molality, it is the moles of your solute over the kilograms of your solvent. The molality is small letter nga M. Then you have your weight percentage. If you're given with the grams of your solute, okay, in every 100 grams of your solution, this is the ang imong mix na nga solution for given. Then times mo sa percent. Yung mga unit for your weight percentage is weight per weight. You have here volume percent. We're given with ml solute. Divide mo lang siya sa 100 and it is the percent solution. Okay, therefore it is percent volume per volume. Then you have weight to volume percent. It is weight per volume. Mabalaan mo kung weight per volume. Panambalaan kung weight na siya, ang unit is in grams. Ang ida ng imong solute or solution is in ml. Then you have your parts per million. Okay, your parts per million is ppm. It is the grams of solute divided by ang grams of solution times 10 raised to negative 6 times negative 6 is 10 raised to 6. This is in a million nga value. Then you have your parts per billion. If you are talking about billion, it is 10 raised to 9. You have grams of solute over grams of solution times 10 raised to 9. It is ppb. And yung ppm is parts per million. Okay, an alternative expression for your weight percent is in equals to grams of your solute over grams of solution times 100. You can use similar alternative expression for your volume. Same lang yapon, change mo lang itong volume of your solute over volume of your solution. Then, pwede man siya gyapon weight per volume if you have here grams of your solute over the volume of your solution times 100. Now, let us know more sa aton nga molarity kag formality. Both your molarity and formality express concentration as your moles of solute per letter of your solution. However, there is a subtle difference between them. Okay, ang imo nga molarity is the concentration of a particular chemical species. Then for your formality, on the other hand, is a substance total concentration without regarding its specific chemical form. It's either gaseous or liquid mo muna. There is non-difference between your compound's molarity and formality if it dissolves without dissociating into ions. The formal concentration of your solution of your glucose, for example, is the same as its molarity. Okay? For a compound that is ionized in a solution such as your calcium chloride, molarity and formality are different. When we dissolve 0.1 mole of your CaCl2 in a 1 liter of your solution or yung mga solute, okay, the solution contains 0.1 mole of your Ca and 0.2 mole of your calcium. Sabihin ni nag-dissociate or nag-disperse ang imong nga calcium. Kung makita mo, nag-ionize, you have your 1 mole of your calcium kag 0.2 mole of your chlorine. Okay? The molarity in mananggaling nga class, okay, it is CaCl4, therefore it is 0 since there is no dissociation in your CaCl2 in your solution. Instead, the solution will be in a 0.1 mole, okay, molarity, it's molarity in Ca and Cl 0.2 molarity in chlorine. Kaya makita mong difference, it is in moles and this is in molarity ng capital M. With the formality of your calcium Cl2 however is in 0.1 F since it represents the total concentration of your CaCl2 in a solution. This is more rigorous definition in your molarity for better or for worse, largely ignored in the current literature as in the textbook. When we state that the solution is 0.1 M, or CaCl2, we understand that it consists of your chlorine ions and also chlorine ions. We will reserve the unit for formality to situations where it provides clear description of your solution nga chemistry. Molarity is used so frequently that we use a symbol notation in simply expressing the equation and it is in writing. Have here square brackets around the species indicates what we are referring to that molarity. For example, here your Ca2 plus, gina-close brackets it is read as the molarity of your calcium ions. Sabihin kung may bracket siya gani, it is in molarity. We have here the solute of dissolved without being undergone ionization, molarity and formality have the same value. A solution of a 0.2059, okay, M or molarity in glucose, for example, is also 0.0259 formality in glucose as well. So, same lang yapon. Change lang yung mga unit. Now, for a normality, yan naman yung class. Normality is a concentration unit that no longer is in common use however because you may encounter normality sa mga old pa nga libro or analytical method, it is very helpful to understand nga may normality pa. Your normality defines the concentration in terms of equivalent, which is the amount of one chemical species that reacts with stoichemically with another element, which is the amount of one chemical species that targets your stoichiometry. Nagliwat ko. Note that it is defined or makes an equivalent and thus normally functions of the chemical reactions in which the species participates. Although your solution like your hydrogen sulfide, okay, has fixed molarity, its normality depends on how it reacts. You will find more detailed treatment on your normality sa Magdalumbangan. Okay, one handbook still use your normality in standard method for the examination of water and wastewater in Joint Republic ng Amerika sa Amerika man lang isa. Now, your molality. Okay, molality is used for thermodynamics calculation whereas the temperature independent unit of your concentration is needed. Molarity is based on a volume of solution that contains solute. Okay, since density is the temperature dependently properly, a solution volume and thus its molarity concentration changes with the temperature. Okay, by using the solvent's mass in a place, the solution volume, okay, will be resulting in the concentration becoming independent with your temperature. So may temperature involved sa aton nga molality. Now you have here weight, volume, and weight to volume percentage. Medyo naguba dito nga symbol. Okay, weight percentage. Kung weight gani percentage, it is percent, weight per way. Then you have your volume percentage, volume. We have also percent sign. And weight to volume, it is weight per volume. Expressing the concentration of the units of your solute present in a 100 grams of your solution. A solution that is 1.5% weight per volume of your NH4NO3, for example, contains 1.5 grams of 0 of NH4NO3 in every 100 grams of solution. Okay, ang mga 100 percent 100 ml ni it indicates like the comparison like in every 100 ml or even every 100 sample na. Now your parts per million or and also parts per billion. Okay, your parts per million is ppm and ppb for parts per billion are ratios that gives the grams of your solute in respective 1 million or 1 billion grams of sample. For example, a sample of steel is 450 ppm in mn. Anong mn? It is manganese. Okay, and contains 4.5 micro of manganese for every grams of steel. We approximately the density of your aqueous solution, which is 1 grams per ml. Then we can express the solution concentration in ppm and also ppb using the following relationship. Okay, you have here ppm, you have your micrograms in every grams, then you have your milligrams in every liter, also have micrograms in per ml, and your nanograms. For this is for your PB na. Okay, nanograms per grams. You have your micrograms per liter and nanograms per ml. For gases naman, okay, usually expressed in the volume ratio. For example, your helium concentration is around 6.3 ppm, means that 1 liter of your air contains 6.3 microliters of your helium. Yeah, you should be careful using your parts per million and also parts per billion to express the concentration of an absolute solution. The difference between a solute concentration that is milligrams per liter and nanograms per grams, for example, is a significant in the solution density and it is not in 1 grams per ml. For this reason, many constitution advise against using your abbreviation like your ppm and your ppb. It is in doubt including the extract units such as your 0.53 micro lead per liter. Okay, and also the concentration of your lead in sample water. Okay, converting between concentration ng units. The most common ways to express your concentration in analytical chemistry also are your molarity, your weight percent, and also volume percent, at kag ang imo nga weight to volume percent. Ang aton nga parts per million kag so parts per billion is yearly lang ginagamit because to ganing gina-warning na nga it is not that exact as it is. Okay, the general definition of your concentration in your equation, it makes it easy to convert your concentration units. You have here your basic equipment sa aton nga quantitative chemistry. You have here the array of equipments available for making analytical measurements and working with analytical samples in impressive and ranging from your simple to inexpensive. And also sa mga complex kag expensive na nga mga equipments. There are three exceptions with the measurement of your masses, also measurement of your volume, and kag drying sa imo nga materials. We will postpone the discussion a few minutes later sa atong mga further pang topic. Here you have your equipment for measuring your mass. Okay, the object mass is measured using the digital, electronic, analytical balance. Okay, electromagnet leviates the sample above the pan and permanent cylindrical magnet when we place an object on a sample pan. It displaces, okay, the sample pan downward by a force equal to the product of the sample's mass and it's accelerated due to the gravity. The balance detects this downward movement and a counterbalancing force is increasing the current to the electromagnet and the current needed to be reduced to balance uh, to its original position so the proportional to the object's mass. Kaya typical electronic balance has the capacity to weigh around 100 to 200 grams and can measure a mass as their nearest or ang nilang ranging value which is 0.01 milligrams to 1 milligrams. Okay, so may makita ka nga different. So, amo ni sa ang picture kaina sa if you have tatlo tubulang measurement nga galinlain. So it is a electronic balance. Okay, so electric siya. Then you have here, although we tend to use interchangeably the terms weight and mass, the important distinction between your mass, okay, from your weight. Okay, the mass is the absolute amount of matter in an object measured in your grams. However, ya class, ang imo nga weight, okay, it is the measurement of your gravitational force acting on your mass. Therefore, ang imo, for example, kung mapakilo kaya lang siya sa gwa, keg magpakilo kayo sa gwa, it is not only the way mo lang, but also the gravity affecting your body. Okay? Ibig sabihin, kung ari ka sa earth, okay, magpakilo ka di, you will be heavier compared mo kung magpa-weigh ka dito sa moon, where is the gravity is much lighter. Gets? Ang ibig sabihin ni nga importante ang aton nga electronic nga balance ni, because it displaces your material or the sample anay para hindi siya maapektuhan sang gravity, measuring only your mass lang gid. Now, moving on, sa aton di nga ito nga mga equipment. Okay? An object is a fixed mass, but the weight depends on the acceleration due to the gravity, which variably sa aton nga location. The balance measures an object's weight, not its mass. Okay? Because weight and your mass are proportional to each other. You can calibrate a balance using the standard weight whose mass is traceable to the standard prototype for the kilogram. A properly calibrated balance gives an accurate value of an object's mass. Okay? If the sample is not moisture sensitive, a clean and dry container is placed on the balance. A container's mass is what you call your tagay or tear. Most balances allow you to set a container tear to the mass of 0. The sample is transferred to the container and the new mass is measured with the sample mass determined by the subtracting that tear at the target. A sample that absorbs the moisture from the air is treated differently. A sample is placed in a covered weighing bottle, then combined mass is determined. A portion of the sample is removed on the weighing bottle and the remaining sample is reweighed. The difference between the two masses gives the sample's mass. Several important precautions help to minimize the error and when we determine the object's mass. To minimize the error of your vibration, the balance is placed in a stable surface dapat in a level position because the sensitivity of the analytical balance is sufficient to measure the mass of a fingerprint material. Often, we handle using a tongue or mga laboratory tissue. Also, din mga volatile liquid sample must be weighed in a covered container to avoid the loss of sample due to evaporation. To minimize the fluctuation in mass due to air currents naman niya class, the balance pan is often housed in a windshield. Paras na windshield na. Okay? Duwara siya sa container, that is your windshield. Para hindi paglupad doon sa hangin ang mga powder materials nyo or sample. Okay, the balance, the sample that is cooler or warmer than the surrounding air will create a convectile air current that affects the measure of its mass. So this reason, bring your sample to the room temperature before determining their masses. Example B, ang mga sample halin pa sa refrigerator. Okay? So cold iyang temperature. So let it to anay or stabilize mo siya sa room temperature anay before measuring it. Finally, samples dried in an oven are stored in a desiccator to prevent them from reabsorbing your moisture from the atmosphere. Okay, environment for measuring your volume. Okay, analytical chemistry use various of glasswares to measure your volume, including your graduated cylinder, your volumetric pipette, and also yung mga volumetric na flask. Okay, the choice of what the type of glassware to depend on how accurately and how precisely we need to know the sample volume and whether we are interested in the containing of or delivering the sample. First, so you have here your graduated nga cylinder. Okay, it is the simplest device for delivering a known volume of liquid reagent. The graduated scale allow you to deliver any volume up to the cylinder's maximum. Okay, typical accuracy for your graduated cylinder is positive negative 1% of the maximum volume. Okay, a 100 ml graduated cylinder, for example, is accurate to plus or plus or minus 1 ml. Have your picture of your graduated cylinder. Next, your volumetric pipette provides more accurate method for delivering a known volume of solution. Several different styles of your pipette are available. Two is which showing there is a dalom. You have here two types of your volumetric pipette. Transfer pipette provide the most accurate means of delivering a known or known volume of your solution. Okay? A transfer pipette delivers less than 100 ml generally generally is accurate to 100 of your ml. Larger transfer pipette are accurate to the tenth of an ml. For example, okay, my 10 ml transfer pipette, there is the low. Have here 10 ml. The 10 ml. Okay, dapat dira lang gid ang imo nga volume kung magputang ka sa pipette nga na. Okay, you see the difference between your two pipette. Okay, pwede ka di ka-adjust sa mo ni klase ng pipette. Pero diri sa ato nga transfer pipette, you cannot adjust this one. Dapat gamiton ni sa dapat 10 ml gid nga volume ang imo nga kuhaon. Okay? We will deliver 10 ml with accuracy of positive negative 0.2 ml. 0.02. You have your volumetric pipette. The pipette on the top is your transfer pipette, and the pipette on the bottom is your more measuring pipette. Or more measuring pipette can measure depende kung pila ang iyang capacity. For here example, pila ni sa nakabutang di? This is, yeah, it is 10 nga ml man. Okay, you have here. Ikaon gid sa itong picture. But this is, I think it is 9 ml. Sabihin, if full gid ni siya hasta sa may pinakababaw ya, which is your 0, okay, it is 10 ml. Then, kung makukuha ka lang 1 ml, from 0 to 1, amo na i-dispense mo. Dispensing is, amo na pagpa-release mo sang liquid halin sa graduated pipette. Graduated pipette. Sa imo nga transfer pipette or sa imo nga more measuring pipette. Okay? To fill the transfer pipette, use a rubber suction bulb or yung tawag na nga aspirator to pull the solution up to the calibration mark. Never use your mouth or ginatawag na nga mouth pipetting because that is old na nga practice gina wala na gina ubra subong. Again, it is ginano na sa aton nga laboratory standards nga hindi ka na pwede ka perform for your safety man. Okay? After replacing the bulb with your finger, adjust the solution level with the calibration mark and dry the outside of your pipette with your laboratory tissue. Allow the pipette's content to drain into the receiving container with the pipette tip touching the inner wall of the container. A small portion of your liquid remains with the pipette tip and is not to be blown out. With some measuring pipette and solution, remaining the tip must be blown out. Delivering your microliter volume of liquid is not possible using your transfer pipette or measuring pipette. Ang tawag ta nga digital micro pipette, which may be vary a volume range from our routine measurement or microliter nga volume you have here nga mga digital pipette. Munsa ginagamit na mo sa mga clinical laboratory because repetitive ang amon nga obra kag small volumes man lang. Kag adjustable ni kung pila ka volume or micro liter ang imo nga kuluhaon. Okay, your graduated cylinder pipette deliver known as volume resolution. And yung mga volumetric class naman niya class, okay, on the other hand, contains a specific volume of solution. Okay, when it is filled sa iya nga calibration mass, calibration mark. Your volumetric flask contains less than 100 ml generally is accurate to 100 of ml, whereas the larger volumetric flasks are accurate to the tenth of an ml. Okay, for example, your 10 ml volumetric flask contains 10 ml. It's either positive or negative ang iya nga 0.02 ml nga unod yan na. Okay, kung puno siya. It's either 0, 10.02, okay, 10.01, 10 ml, or 9.99 ml, 9.98 ml. Amo niya nga measuring day. And also kung imo nga 250 nga ml mass, okay, contains either 250 gid yang ml, positive or negative 0.12 ml. Now, collection of your volumetric flask with volumes from roughly from 10 ml, 50 ml, 100 ml, 250 ml, and 500 ml. So makita mo ang ilang nga capacity sa ilang nga indicator. Okay, let's proceed. Okay, because your volumetric flask contains a solution, it is used to prepare a volume with accurate known concentration. Transfer the reagent to a volumetric flask and add enough solvent to bring the reagent into your solution. Continuing adding the solvent in several portions, mixing it thoroughly after each addition, and then adjust the volume to the flask for your calibration mark using your dropper. Finally, complete the mixing process by inverting and shaking the flask at least 10 times. So it is used for combining your solvent and your solute. Okay, para dili ka na lang diktado yun. Ay, although we have beaker man muna, pero for your flask, okay, for your volumetric flask, okay, the shape itself, okay, gives you a leeway for you to shake the solution inside para ma-properly combine siya. Okay, if you look closely at volumetric pipette or your volumetric flask, you will see markings similar to those shown in your 2.5, and this text marking each watch you will be used for reading. Mga markings na indicating the level kung sa diin, for example, here, pila ni sa compound. You have 10, you have 50, so this might be 50. For this 50 ml, you have here a marking, so dira asta it is 50 ml. Na. Okay, you should closely look, if you look closely, check them. Now, in the case the pipette calibrate to be the to deliver. Okay, may mga muna, if you have mga to deliver nga pipette, okay, your 10 ml solution with necessary around 0.02 ml at the temperature of 20 degrees. So this is room temperature. Okay, the temperature is most likely important because glass expands when contact with changes in your temperature. Okay, thus the pipette's accuracy is less than 0.02 ml. Okay, for higher lower temperature. For a more accurate result, you can calibrate your volumetric glassware at the temperature where you are working by weighing the amount of water contained or to deliver and calculate the volume using the temperature-dependent density. You have here an example of your transfer pipette. Okay, for your this is 10 ml. Yeah, transfer pipette or more transfer pipette, measuring pipette. The volumetric flask has a similar marking but uses the abbreviation for your TC. Ibig sabihin, TC is to contain in place of to deliver. Nga man to contain. Kay mas, di ba container mo siya sa imo nga container which is your volumetric flask. Compared mo sa imo nga pipette which is to deliver. Okay? Wala yagid gina-hold ang volume niya but gina-measure mo lang da kag i-transfer mo into another container. Okay? You should take 3 additional precautions when working with your pipette and volumetric flask. First, the volume delivered by the pipette or contained by your volumetric flask assumes that the glassware is clean. Ibig sabihin, dust-free because your dirt and grease on your inner surface prevents your liquid from draining evenly, leaving some of mga droplets sa sulod sang imo nga glassware kasi sa imong sulod sa imong pipette or sa sulod sa imong volumetric na flask. And also, for pipette, this means that to the delivered volume is less than your calibrated volume, while drops of liquid above your calibration mark means that the volumetric flask contains more than its calibrated volume. Immensely available cleaning mga solution are available for cleaning your pipette and mga glassware aside lang sa imong mga volumetric flask. Okay, second, when filling your pipette or your volumetric flask, okay, level must set exactly in the calibration nga mark. Okay, the liquid top surface, okay, is curved into a meniscus. Okay, the part or sa bottom part of which you should align the glassburst calibration mark you have here. Dito sa akong image. This is your volumetric flask. Okay, ginpasudlan niya water asta diri sa babaw. Okay, ang water arada sa top line sa imo nga calibration mark. Tama, because the meniscus dapat ang bottom end sa imo meniscus ang ara sa imo calibration mark, not the water or that the top level of your water. The calibration, the meniscus ang gat-touch sa imo nga calibration mark. Okay, in order to do this, okay, you need to place your calibration mark, okay, at your eye level. Okay, wala ka gatanga, way ka gaduko, but dapat equal gid ang pagtulok mo sa imong nga calibration mark. Finally, before using your pipette or volumetric flask, rinse it with several portions of your solution whose volume you are measuring nga aman to ensure nga na-remove na ang any residual liquid remaining in the pipette or volumetric flask kung gingamit mo ni siya previously. Hindi siya contaminated with other nga mga solution. Next is equipment for dyeing or drying samples. Many materials need to be dried prior to their analysis to remove residual moisture. Depending on the material, heating to temperature between 110 degrees Celsius and 140 degrees Celsius usually is sufficient. Other than materials need to be heated higher temperatures to initiate thermal decomposition or maguba siya. Okay, conventional drying ovens provide the maximum temperature around 160 degrees Celsius to 325 degrees Celsius depending sa mga model yan na or kung ano man ang latest subong. Some ovens include the ability to circulate heated air which allows for more efficient removal of your moisture. Kaya nga man, aside sa ginapa-dry up mo siya, ang moisture is makita mo sa environment. Okay, para hindi magbalik ang imo moisture sa imo nga sample. I-eliminate ka man na aside sa ginapa-dry mo ang imo nga sample. And shorter your drying time. Other ovens provide tight seal for the door which allows the oven to be evacuated in some situation. A microwave oven can replace a conventional laboratory oven. Higher temperatures up to as much your 1,700 degrees Celsius okay, requires for muffled nga furnace. Here an example of your muffled furnace. Okay, after drying or decomposition of the sample, it is cooled in your room temperature in desiccator to prevent the reabsorption. Okay, desiccator. Okay, a desiccator naman niya class here. Okay, is a closed container that isolates the sample from the atmosphere. Nga man, the atmosphere has humidity in it. Okay, from mga evaporate nga mga sweat sa environment okay, or kung cool man mismo ang imong place. Okay, the chances of your sample to reabsorb the same water content sa atmosphere is high. So, ibig sabihin, i-isolate mo siya. Kaya drying agent called your disinfectant. Okay, is placed at the bottom of your container. Okay, the typical disinfectant include your calcium chloride and silica gel and perform a plate sit above your disinfectant, providing a shelf for storing samples. Some disinfectors includes a stopcock which allows them to be evacuated. Your stopcock is the mga cork. Okay, kita nyo na sa wine na bilang sa iyang takop na balas ng wine. So, amo man na. Okay, para mas stilyado siya. You have here an example of your desacchitator. The solid at the bottom of your desacchitator is your desacchitant, which is in case of your silica gel. Okay, so that includes our chapter 2, and you will be seeing more sa on chapter 3, and so on and so forth. Thank you, and God bless, good kids.